Hello everybody, my name is Alex from COVI, and today I have the pleasure to present our paper, Shaft Capacity Aging Trends of Onshore and Offshore Piles with Rhythm and Sand. My co-authors are Professor Richard Jardine, as well as Rui Silvano. What have you done? Quite easily, basically, we have used already existing two data sets for pile aging capacities. We have used the very unique offshore large diameter pile data set from a recently published PAGE project, as well as a quite common onshore pile aging database with quite smaller piles. And there on top, we have just put 3 large diameter piles from Cuxhaven installed onshore, as well as a set of micropiles. This kind of set of micropiles from my PhD thesis, 9 piles mild steel piles, 9 piles stainless steel piles. And all of this was then later on normalized by XCPile capacity prediction methods to see if we can predict some trends. Therefore, we have used the methods ICP05 and the unified method. Let's directly dig into the data. Here, for example, you can see the piles over time. We can see every kind of data point represents a pile capacity for a certain time divided by its initial capacity. We can see yellow as there are the onshore piles. We can see in blue the offshore piles. We can see the purple crosses are the mild steel piles, the micropiles, and the green crosses are the stainless steel piles. And there on red, the triangles, these are the large Cuxhaven piles. What we can see is that it's quite hard to fit any line through all of these data points. And basically, it's quite hard to predict anything. We can be a bit conservative, averaging something in the middle, but then it would be probably not reliable at all. We have one trick left. We can start normalization in the hope that all of these differences are just based on diameter, different soil conditions, whatever. And in the hope we can cancel all of this out and we can cancel out the known factors and we can amplify the unknown factors. By doing this, using the unified method, for example, now each data point is normalized by its predicted pile capacity, not by its initial pile capacity anymore. So please watch out the y-axis. We can see that the scatter is a tiny bit reduced. Nevertheless, still hard to fit anything through all of the data points. And this leads us to the question, why should we not handle different things still differently? And therefore, if we now start to fit some lines through all of the groups separately, we can see that we are quite good in representing these kind of lines and these kind of behaviors at all. We can see that, for example, related to their predicted capacities, the onshore piles, the yellows, are with its highest, with the lowest capacities shown by the stainless steel micropiles, with totally underpredicted all the time. We can even start using some confidence intervals. Here, an 80% confidence interval for the data sets where we have enough data points. For the other one, it makes no sense at all. But actually, that's then a quite good outcome. We can see also that at the end, especially for the unified method, also for ICP and so on, we are getting a bit out of the prediction, but that's quite common, so that's not what these methods are made for, actually. What is the take-home message? If we look at the same plot, we can say that the setup effect, or the pile aging capacity, is depending on 3 different parts. It's depending on the pile diameter, depending on the material, and depending on the environment. Actually, it's also depending on the installation method. We are here only looking on impact-driven piles, but it's a different story. And secondly, if we even normalize all of this data using pile prediction methods, we are still not able to predict everything with just one trend line. Nevertheless, if you now have a pile and you want to predict its capacity into the future, you can use a kind of prediction method, you can use a simple tangent functions, you can use our kind of fitted parameters, and you can predict your pile capacity into the future. Thanks a lot.